So this is the video lesson for 9.2 for Algebra 2, 9.2 arithmetic sequences. And today's date is Wednesday, or when you should be watching it, Wednesday, April 14th. Okay, so for arithmetic sequences, we actually saw a little bit of this on Monday when we were talking about sequences, and we had to know a little bit about how to write those explicit formulas, and some of those were arithmetic sequences. Well, what it is actually, just a kind of definition with it, arithmetic sequence, and we're going to see the other kind on Friday, which is called a geometric sequence, but an arithmetic sequence is basically a sequence which we talked about on Monday, like a pattern, a list of values with a common difference is the vocabulary word we're going to use here. It's also referred to as a constant difference, which I'll write down in just a second. So common difference is also, I'll write down constant difference because it means the same thing. Sometimes you'll see it written one way or another depending on constant difference. They both mean it's like the number that's added or subtracted each time in a sequence. So when you look for that pattern in a list of values and it looks like it's like the same number every time is being added, or like maybe it's adding 3 every time or subtracting 3 every time, or adding 8 every time, or whatever it is, that is called the common difference. And so any kind of sequence that shows where you're adding the same number every time or subtracting the same number every time, like we saw again on Monday, it's going to appear linear. We also saw that on Monday where it's going to kind of have like, if you were to like plot the values or look at the table, it would look like a linear equation. So it would even have a linear type equation. This common difference or constant difference is the letter we use to represent this is the letter D, just like D for difference. Okay, so we'll use that kind of, Michigan Virtual uses that also throughout the quiz and the lesson and so on. So to start with, I'm going to start off with just kind of giving you a random sequence, and we're going to make sure that sequence is arithmetic, and I'll show you how we can double check it is. So let's say we have the values 7, 9, 11, and 13, starting with something pretty simple, something very similar to what Michigan Virtual even has. So if I see these values, I could then try to find a pattern, which is probably the first thing you always want to start with doing. So we are adding 2. Sorry, this pen is not great. Okay, let's see if this is better. We are adding 2 every single time. So that's how I know that this is an arithmetic sequence, first of all, because I'm adding the same number every time. And then if it did ask me what is the common difference, then I would be able to identify it as 2. It's a positive 2 because it was adding 2 every single time. So it's always based on whatever the sign is. If it's positive or negative, that's how you would see that D value or difference. And then if we were to write the equation for this, which we'll do later on, it would be written like a linear equation. Here's another example just so you can see that it also works for subtraction. Say we have 87, 83, 79, and 75, and these could keep going. I'm just writing down about 4 terms just to give an idea. So if we see those 4 terms, and again, we're trying to figure out what is the sequence, it is again arithmetic. In case you're having trouble saying this word, it is called arithmetic and not arithmetic. So make sure you're not kind of confusing those in the future, especially when you see that word again. Arithmetic just kind of tells you that it's going to be a sequence where you're adding or subtracting the same number every time. So we are subtracting 4 this time on all of these terms. So -4 each time does give you each number before it, right? 87 minus 4 is 83. When you subtract 4, you get to 79, and so on. If it is not the same number every time, then maybe it's not an arithmetic sequence. It could be geometric, or we haven't worked with any that are kind of neither, but it could be neither one of them. So this time D here is a -4 because I was subtracting that number every single time, subtracting 4 each time. All right, now what we're going to do is we're going to take these arithmetic sequences and we can write them, their equations or their functions, basically using different formulas like we saw on Monday as well. We talked a lot about recursive, explicit, so we're going to bring those two up again. The quiz doesn't have much with recursive formulas, but I will show you what it is in case you just want to see what this would be. So we can use arithmetic sequences to write all of the different forms. I will tell you for the quiz, you should know at least the explicit form. There are 2 ways that we can write it for the explicit form, so I'll show you both of those ways. So if we were to use recursive, remember it's where you use the previous term in the equation. So you're going to show how you start with the previous term and you either add or subtract a number after it. That we'll see with the recursive. It's usually the easiest one to come up with. That's why some people might prefer this, but it's not the best one in terms of finding what happens like further towards the end of the sequence. Like I don't want to, if I'm trying to figure out what happens on the 100th term of the sequence, I don't want to really use recursive because I would need to know the 99th, for example, then. And that would be hard to come up with sometimes. So let's use an example. For explicit, I will tell you that there are going to be 2 ways that we can use the explicit one, and I'll show you what those 2 are in just a second. So first of all, let me give you an example that we'll work with for each of these scenarios. Here it is. Let's say that the sequence, we're going to say for the arithmetic sequence, we're going to use this same sequence over and over again for those 3 forms. And it's going to go 29, 24, 19, and 14. I usually leave a space right here in front because we, like you saw on Monday, we're going to find those y-intercepts if we need to on some of those examples, so we'll start with that. So that right there is my sequence. The first thing you want to do is find the pattern. I'm subtracting 5 every single time. So that's how we know that it is definitely arithmetic, and D is -5. So we do know that much. All right, so then you would start with, here's recursive. So for each of these scenarios, I'll write down recursive and then the 2 explicit. We won't do it over and over again, but recursive would just be as simple as saying a sub n, or you can use any letter, s sub n or whatever, and you would write a sub n minus 1, saying that you're going to use the previous term before the one that you're trying to find, and all you're doing now is subtracting 5 from it. So for recursive, it's as simple as just saying the previous term plus or minus whatever number. But again, this is not always used because in order to use this, we'd have to know, you would only just find the next few terms. You wouldn't go on to find the 100th term, because in order to do that, we'd need to know like the 99th term, basically the one before it, right? So if I was looking for a sub 100, I would need to know a sub 99 here. And I don't know that, so that's why this isn't always used. Explicit, though, is definitely much more handy. And again, there are 2 ways to write explicit formulas. One is called with the 0th term. Basically what this means is what we saw on Monday with like the y-intercept. So I'll put that in parentheses because that's essentially what we're going to be doing, using the y-intercept or the explicit form. The form for this explicit formula will always be similar to y equals mx plus b, but here's what it looks like with sequences. A sub n equals a sub 0, which means, and I'll label each of those parts, but it's like your initial or what happens with, that's like your y-intercept, plus d times n, or dn. And so if I label each of these parts, I have here a sub 0 is the 0th term or the initial term. I'll write 0th term. I know that looks odd. It's also called your y-intercept. The d is the same as the common difference that we've been working with, which is also the slope. And then we have our n, which is just the term number. So if you're working on finding this third term or whatever number you want to find, and then that would be your nth term. So what you end up getting for your answer for that. All right, so let's use the same example as this and try to write the explicit formula using this kind of model. So we would say a sub n equals a sub 0, I don't know yet. Okay, so I'll just keep it a sub 0 for a second, plus d times n. Now d we know is -5. But in order to find more of this, well, I actually just need to find that guy right there. I can leave n and a sub n because that's how I write a rule. But to find my a sub 0, that's where we did yesterday, or on Monday, where I would think about these as like your n values as far as placement. You can make like a little table out of this because you know which term is what, and you're trying to find the 0th term. So you would say, instead of subtracting 5, because you're going backwards now, you would add 5. So 29 plus 5 is 34. That would be my y-intercept, or my 0th term. So I would write this as 34 minus 5n. That might be the way that Michigan Virtual writes it. Again, they could write it in recursive, but it's just not used as frequently. And then we'll show one more way that could be written as well. So the final way that Michigan Virtual will explain explicit formula is without the 0th term, because sometimes it's kind of like you have to find that extra piece each time then. So if you're trying to avoid having to do that, there is one more formula that's used, and this is with the first term. So if you just want to use that first term that's there and just kind of ignore the y-intercept, like don't even bother finding it, all you would do then is, here's the formula for this one. And you could either memorize this or you can refer back to it when you take your quiz and test. Here's what it looks like. It's a sub n equals a sub 1 plus d times n minus 1. So again, if I was to use this generic formula, and actually I will kind of box these, because you can come back to them. And then the answers that we're writing are all here. They're all going to be equivalent. So these all will mean the same exact thing. It's just different ways, like different representations. So if I was to use this, again, I'll label each of the parts. This time, a sub 1 is the first term, not the 0th term. D is still your common difference, which is your slope. And the n is still the term number, which we leave as n because we're trying to write an equation essentially. So to find the answer here, we are going to substitute as much as we know. We know the first term here is 29. So this would be written a sub n equals 29 plus the d was still -5. If you don't want to write a plus and a negative, you could just change that to a minus, and then n minus 1. That would literally be how you leave your answer. And I know it doesn't look like it's simplified. You don't have to simplify it, but if you were to simplify this, it would actually end up giving you that simplified version. So like if you were to actually distribute this -5 in, I can show you real quick what that would be. You would get -5n plus 5, 29 is still sitting there, and this simplifies to 34 minus 5n, which is exactly what I had here. You don't have to do this simplifying though. You can, that's why you would just use one method versus another. Again, it'll depend on how your answers are left for Michigan Virtual. So some of the answer choices are going to be in this form and some will be in this form. So you just want to look at your answer choices, but of course, and you can decide which method you want to use. Let's say you use this method right here, the 0th term, you get your answer and you don't see the correct answer there. Let's say this is not one of your answer choices, but there's something that looks like one of these forms where there's a parentheses and n minus something in the parentheses. You could either decide to simplify by multiplying through in that parentheses for that answer choice and see does it give you the answer you came up with, or maybe redo the question, finding it using the explicit formula with the first term instead. That's why there are many methods that can be used. So you definitely want to know more than just one way. I know we focused on this way on Monday because at the time we didn't really want to just do arithmetic. We were kind of doing the sequences in general, but that's kind of what this looks like. So we'll practice one more of this kind, and then we'll go on to one last question that you would see on the quiz. So we have, here's another example. We have a question that might read something like, find the formula for the following sequence. Arithmetic. It's telling us it's arithmetic, but these all will be for the quiz anyways. And here is the sequence. So this time it's going to involve some fractions. Don't let the fractions kind of scare you, but we'll work through this because there's a few questions that you'll see fractions on, even on the Michigan Virtual Quiz. So let's say it's 13/3, 17/3, and then a 7 and 25/3. Now, when there's like a whole number like this thrown in, that's because it simplified whatever would have been here. So when you go to look for the pattern, you might have to see that. So let's find the pattern. When you see that the denominators are all the same, now of course the 7 isn't. If you want to rewrite that though, how could we rewrite 7 so that has a denominator of 3? That would be 21 over 7, or sorry, 3. That does, obviously divide to give us 7. So you can kind of just imagine that could still be 21/3 if that's easier to see. And we're saying, how do I get from 13/3 to 17/3? Notice if the denominator is the same, that means that you're either adding or subtracting with the denominator of a 3, because when you add common denominators, that's how you get the new numerator. So 13 has to turn into 17, where the 3 is still the denominator. So I would add 4/3, because 13 plus 4 is 17. Check to see that that works for all the rest. 17 plus 4 is 21. So yep, that works. And then 21 plus 4 is 25. And again, the denominators all stay the same. So what I just found is that D is 4/3. All right, and then I would find in order to write the equation here, you can again use one of the two explicit forms. Let's not bother with the recursive. You can, but it's just, again, not used very often. So you can decide which explicit form to use. If you're going to write it using the first term, like this one, you can absolutely do that, but then you'll have to simplify most likely further to get to what the, kind of the form that looks like y equals mx plus b essentially. So I'm going to go ahead and just find the 0th term, because I believe the answer choice is going to be left like this, where I need to figure out how I would go backwards. So 13/3 minus, or I can write subtract 4/3, would be 13 minus 4, which is 9/3. Now 9/3 can be reduced though to 3. So that's how I would write, that would be my y-intercept, 3. Okay, so let's write down one of the forms. I can write both if that would help to see both, but you don't have to obviously do both each time. It just depends on how your answer choices would be left. So from the front page, if you remember, we start with our a sub 0, which is 3 that I just found, plus the D is 4/3, and then N. This is the final answer if you're writing it in this form, or if you were to use the other form, then it was a sub 1, which is 13/3, plus there was a D, so 4/3, and then N minus 1. So both of these are absolutely the same. I will tell you though that Michigan Virtual, I don't believe, left the answer like that on this question. The one with the fractions, it was left like this, but they are both equivalent. It's just using a sub 1 versus a sub 0. And depending on how your answer choices are left on the multiple choice questions on the quiz or the test, that's the method you're going to want to use. So again, feel free to pick whichever one. That's the idea. All right, so that's one of the fraction questions. You probably have 2 of those, but same idea for each one. Just kind of use, if the denominators are all the same, just find how am I changing my numerators and put that denominator on the bottom. This would work the same way if it was a minus. Say you were subtracting as you were going to the right, then make sure you add as you go backwards to find your y-intercept. And always reduce the fraction 9/3 reduced to 3, but be careful with your addition and subtraction because the wrong answer might be sitting there too. All right, for our last type of example that we're going to see, it's something, again, that's on the quiz. There's a few questions like this. It'll say, find the value of r sub 1. That means the equation of like the first term where r is going to be like the letter we use instead of a sub n, it'll be using like r sub n essentially. But any letter could be used for that. It doesn't have to be r. And d is the common difference. So we're going to try to find both those things. The first term, that's going to be first term, and common difference or slope. It won't tell us that's what it is, but I'm writing this down so that you know what you're looking for. R sub 1 and D for the arithmetic sequence with, and then here's where it's going to give us some more information. This one will be R sub 5 equals 6, and R sub 7 equals 7. So if that was the question that's given to us, this time if you notice there's no sequence actually given. There's just giving us two numbers that are part of the sequence. So what you would start with is it helps if you make like a table for yourself. And what I know is that the fifth term is 6. That's what this means. Fifth term is 6. This means the seventh term is 7. Okay, so we can go ahead and put that in here. If I kind of imagine this is my n and this is my, I'll call it r sub n because we're using the letter n, r earlier. That's what the question used. So you can use any letter, but they're using r. So n and r sub n. So we know that at 5, because it's further down here, 5, it is 6 is the value there of r sub 5. And then if I skip 6, because I don't know that one, I know 7 is at 7. That's all I know. That's all the information that was given to me in the problem. And now I'm asked to find the common difference and r sub 1. So if you're able to, you can kind of just look at this and say, well, what would go in this, in between here, between 6 and 7, what's halfway between there? That would be 6.5. So if you can figure it out because of how the numbers are spaced out, you can absolutely do that. If you can't do that, because the reason we're filling it in is because it's going to help me then to find the slope, right, or the d value. I'm basically adding a half every single time to get to the next term. So my d is 1/2. But again, if I couldn't figure that out, I can use the slope formula, which says subtract your y values, 7 minus 6, and then divide it by the x value subtracted. So this would be 1 over 2, like I just found. So this is like the more algebraic way of finding it. Here, you can kind of just use a table to help you find the values. So slope formula or table, either way, we find that d is 1/2. Okay, so we're getting closer to our final answer. We found d. Now we need to find r sub 1. R sub 1 would mean what happens if I go backwards here, 3, 2, 1. I want to know at the first term what this will come up to. So if the numbers are not so large, you can work your way backwards and keep filling the table in. So I could say, okay, I'm going to subtract half as I go backwards. 5.5, 5, 4.5, 4. So I found the answer that way. And I could say then that r sub 1 equals 4. Let's say they weren't so close together. What if these numbers were way up in the 20s or the 30s and I don't want to count that far, back? I could instead use one of the formulas. So another way I could do this, and again, this is more work, so I don't recommend you do this unless you absolutely have to, would be to either use the a sub n equals a sub 1 plus d n minus 1 formula, explicit formula, or even you could use a sub n equals a sub 0 plus dn formula. And we would fill in, everything into it and solve for the missing part, which in this case, actually, I'm going to change these to r's only because it's r sub 1 we're looking for. So that would be r, these would be r's. This would be r sub 0. But in order, if I was to use this equation, I would find the 0th term. I would still need to go to the next term to get the first. So I don't actually probably want to use that one. It's probably more helpful to use this one. So if I was to use it, we're looking for r sub 1. I don't know what it is. I do know that d is 1/2. And now what you would do is you would plug in any n with r sub n that you know. So for example, I could use the first one. At r sub 5, that means at the 5th term, I could find r sub n would be 6, right? So I'm substituting in n and r sub n as like your x and y. It's like an ordered pair. And then you just simplify and you solve for r sub 1. So this would be 1/2 of 4 which is 2. You could subtract the 2 to the other side, and that's how you get 4 is r sub 1. So that's like a more generic way, or like algebraic way of finding the same answer we did here. This is much easier, of course, if you can just use your table to fill in until you find it. But if you can't, feel free to use this, or even this. It's just, this would be the same about the same number of steps, and then you would still have to go back to find r sub 1. So I don't think it's the most helpful. All right, so there's 2 questions like this on the quiz, just similar to this, maybe a little more spaced out. Again, if they are more spaced out and it's hard for you to come up with the D, use the slope formula. All right, this is going to help you. If you need the slope formula, it's y2 minus y1 over x2 minus x1, which is essentially what we did here. If you treat these as like x and y values, that's essentially what they are still. It's just in terms of a sequence. All right, so if you have any questions on any of this that we covered in the video today, just send me an email. Since we don't have our usual schedule for the afternoon, I can try to meet by appointment if you do have a question still, even though I know many of you might be still taking the SAT tests or the work keys tests. So if you're all set, otherwise, just complete that Google form for attendance and take that quiz when you're ready for section 9.2. And I will see you guys on Friday. Have a great day.